Now we have to put completing the square to work. We're going to use the process of completing the square in order to help us solve a quadratic equation. We'll use this in combination with solve by taking square roots. So that same process that we did before in section 5.5, we're going to use here in section 5.7. All right, so this should be all right. As long as we understand how to complete the square, we should be able to use completing the square to solve an equation. All right, so I have sort of an easier example and then maybe a more difficult example to follow. So first of all, remember that when you complete the square, you take your b value and you divide it by 2 and square it. All right, so that helps us complete the square. Now keep that in mind that this is an equation now that we're working with and not an expression, so we do have to be careful in how we approach. So the first thing that I want to do is actually move the constant to the other side of the equation. So I'm going to add 16 to both sides. I left myself a little bit of space because I'm going to add a number on both sides to make sure that I get a perfect square here on the left. Now, 6 divided by 2 is 3. All right, 6 divided by 2 is 3. I'm going to take 3 squared, which is 9, and I'm going to add that on both sides. That's a funny way to write it. But for safety's sake, that's the way I'm going to put it, just to make sure that we are all on the same page. When I do that, that becomes this expression on the left. So this expression on the left is now x squared plus 6x plus 9. This is really kind of a silly step, but I am going to write it, again, just for safety's sake today. And this gives us 16 and 9. So all that I did was I added 9 on both sides here. So it remains an equation. These remain equal to each other. This gives me x plus 6 over 2 was 3 squared. And over here, this is 25. 16 plus 9. Now I can solve this by taking the square root on both sides. Keep in mind we have a positive root and a negative root. So the square root of x plus 3 squared is just x plus 3. And the positive negative will kind of sort itself out. But over on the right side, when we take the positive and negative square root of 25, we've got to be concerned about the fact that there's a positive 5 and a negative 5. To solve this equation, I'll just subtract 3. Now here's where it gets maybe a little cumbersome in how we do our work. But x here is going to equal negative 3 plus or minus 5. All right, now this is kind of a weird statement to make because we're going to take negative 3 plus 5 and we're going to take negative 3 minus 5 to get our two separate answers. All right, so that means that x is equal to negative 3 plus 5 and x is equal to negative 3 minus 5. And that gives us our two solutions. X is positive 2 and x is negative 8. Now this is pretty fancy when it works out nice and pretty like so. Just a little hint, if it ever works out with nice integer answers, that means that there was probably a better way to solve this, namely solve by factoring. It's probably the better approach here. And some of you may have seen this originally when I had this example listed here. You would say, oh, well, factors of negative 16 that add up to positive 6 would be a positive 8 and a negative 2. And then, of course, we could solve it accordingly to find that if x plus 8 is equal to 0, then that means x is equal to negative 8. And if x minus 2 is equal to 0, then that means x is equal to positive 2. So you could have solved this. You could have solved this by factoring. However, the directions here were to solve by completing the square, so that's what we get to do. In some cases, however, the examples will be a little bit more tricky. So that's what I've got going on the right-hand side here. Again, we want to complete the square. So our first step is move the constant to the other side. Once we move that 8 to the other side, then we'll proceed with the process of completing the square. Again, I leave myself some space here because I'm going to add something on both sides. I'm going to add 10 divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 on both sides. Now, I'm going to skip a step that I did on the left-hand side, so bear with me. If you need to write that step, then leave yourself a space so you can write that step in. But here, I'm going to rewrite this. If I know that this is a perfect square, x plus 5 times x plus 5, then I'm just going to write it as is. And over here, negative 8 plus 25 is 17. And now I have a situation where I can solve this by taking square roots. So now I'm going to do that. Take the square root on both sides. All right, we can't take the square root of 17. 17 is a prime number. It does not have a rational root. It is an irrational number, the square root of 17 is. And so that's what we're stuck with. This is actually maybe even a little easier than what's on the left side. I know that this looks more complicated, but watch. When I subtract 5 on both sides, I can't combine those. And so that means that I'm done. This is my solution. That's actually my solutions. There's two solutions here. Negative 5 plus the square root of 17 and negative 5 minus the square root of 17. And that is how you solve a quadratic equation by completing the square. Enjoy.